Okay, so when you draw the inclined plane, remember there's that little triangle inside. Gravity is the hypotenuse of that triangle. Okay, it's the biggest side. And then the angle is the same as the angle of incline. Right? And F parallel is always that opposite side. Okay, I'll give you a few minutes to give that one a try, okay, and then we'll go through it together. Okay, just in case you're lost getting started here, okay, remember that all inclined planes work the same way. Okay, we know that this is a 25-degree hill, right? Okay, child's 50 kilograms, and we know that gravity is pulling straight down, okay? And that will be with 490.5 newtons worth of force, right? Because gravity is m times g. Okay, this side of the triangle here is normal force, and then this side of the triangle here is F parallel, and that angle is the same as the angle of incline. Now, where do I draw friction?
Uphill.
Up the hill, yeah. Okay, that's the direct. Friction always opposes. Once you figure out which way this thing is going, draw friction the other way. Okay, so friction is up the hill. Plus, it tells you that in the question. Because friction, oh no, it actually doesn't. It says resists with a force, but it does say that they're sliding down. Okay, so this force is 150 newtons. Okay, and it's the force of friction. Okay, and then obviously this would be F parallel. Okay, give you another couple of minutes, and then we'll walk through the rest of it. Okay, so we already know what force of gravity is. If I want to calculate F parallel, it's the opposite side of this triangle. So I have to go sine of 25 times the hypotenuse, which was 490.5 newtons. I already pressed that button. I guess not. Okay, sine of 25 times 490.5. All right, so we're looking at 207.29 newtons. Okay, so there's 207.29 newtons going down the hill, 150 going up the hill. Can I calculate net force now? Okay, so that's going to be F parallel plus the force of friction. So that's going to be 207.29 minus 150. And I'm going to make down the ramp positive just because that's forward, okay, for that object. So minus 150. 57.29 newtons. Okay, and then I can calculate the acceleration of the child. F equals m times a, so F net over m. 57 divided by the 50 kilograms. All right, so we've got 1.1, actually we've got two significant digits, so 1.1 meters per second squared downhill. Okay, is that ringing a bell? All right, so what we're going to work on today are some different types of questions, and I made up one on Friday because Mr. Dickey showed me something he had made up and I really liked it, so I'll give credit to him. It was his question, but it's awesome. So we're going to do that later on in class. On the board right now, right under the practice quizzes thing there, are the numbers from the first worksheet in the workbook for this unit that I would like you guys to work on. Okay, so if you're in that first, if you're in that dynamics workbook, okay, so we're looking at, okay, Newton's second law, worksheet number 1. That's what we're working off of. You printed that off, okay? We're starting on question number 5. We're doing 5, 8, 13, 18, 19, 21, and 23. We've done questions like all of these before, okay? We just kind of want to get through them and then start throwing some new stuff at you, okay, after that. Okay, so this is the elevator question. It's basically asking for the 3 different situations an elevator can be in: accelerating upwards, accelerating downwards, and traveling at a constant velocity. Okay, so in the first one, we know that the elevator is accelerating downwards, okay, at 1.05 meters per second squared. Okay, so that means then that the tension has to be less than gravity, right? We know that the mass is 1,200 kilograms. So we can calculate the force of gravity once and not have to calculate it again. So that's going to be 1,200 times 9.81, which is going to be 1,177. No, 11,000, right? 11,778. 772. Okay. Newtons. Okay, so we know that the force of gravity is that much, and we know that the acceleration is 1.05 meters per second squared Dow. Okay, so now that it's spelled right, now we'll know what's going on. Can I calculate the net force? Okay, so F net, okay, is going to be mass times acceleration, so 1.05 times the 1,200. It's like 1,270, right? How about I just start typing stuff in since you guys aren't going to say anything? Okay, 1,260. Okay, 1,260 newtons down. Okay, so now that I've got my net force, then I just do sum of all forces. So that's going to be tension plus the force of gravity. So to calculate tension, I'm going to go F net, which was negative 11,772 minus negative, sorry, that's the force of gravity, net force. Negative 1,260 minus negative 11,772. Okay, I have to make them both negative because they're both down. This is simply a vector problem. Okay, so we'll take our 1,260 and we'll subtract 11,772, and there's our force up. 1.05 times 10 to the 4 newtons up. That's how much tension there has to be in the cable. Right? All that changes for part B is that now it's accelerating upwards. So now all that changes is this. Now the net force is up. The acceleration is the same magnitude, it just changed direction. So now my net force is positive 1,260. Okay, so when I do that, I'm just going to go 1,260 plus 11,772 because it's subtracting a negative. All right, so now I've got I don't know why I have 1.31 there. It should be 1.30 times 10 to the 4 newtons up. Okay, everybody all right with that? Now, when it is moving downwards at a constant velocity, what does that mean? Acceleration is 0. What's F net? 0. So the force of gravity and the tension in the cable are the same number. That's the only way that net force can be 0 is if the force up and the force down are equal. Everyone okay with that? That's why the answer comes out to 11,772 newtons, but to 3 significant figures, it's 1.18. Okay, does that make sense? Hey, any other ones? How many people have done all that? Okay. All right. Let's do the question I had in mind here, just because it's so good. Okay, we got an inclined plane, we got a system, we got 3 masses. Okay, there's no friction anywhere, it's frictionless. Right? But I would like the acceleration of the 5 kilogram box. So you have to integrate a whole bunch of things that we've talked about, inclined planes, systems, all of it. Okay? You'll actually, in the end, be surprised at how little math is really involved in this. Okay, so just as a question, I'm not gonna solve the thing here, but in case you're stuck. How many forces are, let's say, contributing to the movement of the 5 kilogram mass and thus the system overall? Three forces. Okay, there are 3 forces that are pulling on the 5 kilogram mass and thus the system in total. Only 3 forces. Okay? One of them is one that's always present on an inclined plane, and then the 2 acting on the hanging masses. Okay? I'll give you a couple more minutes so you can calculate those. Okay? But in the end, there are only 3 forces that are directly contributing to the movement of this system. How many forces are acting on the 5 kilogram box directly? If that 5 kilogram box wasn't connected to the other 2 boxes, what would it do? It would slide down the ramp. Why? Because of F parallel. F parallel is still here. It's still an inclined plane. Therefore, there are 3 forces directly acting on the 5 kilogram box, and thus the whole system, which is kind of the trick in the question. Okay, so the forces acting in this system are gravity, for that one it's going to be 98.1 newtons, okay, and F parallel, right? Can I calculate F parallel? Yes, okay, so I got a 20-degree angle, okay, I know this is going to be FG, so that's going to be 49.05, okay, and I'm going to get F parallel this side here, okay, 20 degrees, so I'll go sine of 20 times 49.05, okay, there's F parallel, 16.77, okay, and then I've got my force of gravity over there, 78.48, is that right? Okay, can I simplify this diagram now? Yes. Okay, so we got 1323 kilograms. 78.48 going that way. And we've got 16.77 and 98.1 going that way. Okay, can I find the net force? Okay, vector sum of all forces will give me net force. Okay, so that's going to be the 16.77 plus 98.1 minus 78.48. Okay, so there's the net force in the system. Oh, that was multiply. Let's try that again. That number seemed really big. Okay, plus 98.1 minus, boy, the struggle is real, plus 98.1, do what I want. Okay, minus 78.48. Okay, so there's my net force. Divide that by the total mass, which is 23 kilograms. 1.6 meters per second squared. Down the ramp, it asked about the 5 kilogram mass only. Okay, so I still divide by the whole system. That's the system trick. Hey, how much work was there in that? Not much. It seems like it should be a lot more, right? You see that, you go, oh my God, that's crazy. But it's not that bad. Okay, we just apply the things we already know. Tomorrow, I will not be here. You have super sub Mr. Van Erb tomorrow. Okay, so he's great. He can help you with this. Okay, he knows this stuff. So you're going to be working on some Newton stuff, and Mr. Van Erb will be here to help you if you need it. Okay.